Hey, so welcome to the notes for intervals of increasing, decreasing, and constant functions. And to get ready for this lesson, we're just going to talk through a quick mathematical story. So the character in this story, his name is Pierre. He's the mountain climbing ant. And Pierre is here to remind us that we only read graphs from left to right, just how you read a book. Okay, whenever Pierre is climbing a mountain, so he starts here at the left side of the graph, and he's climbing uphill as he goes from left to right. So whenever he's climbing a mountain, that is increasing. Okay, so Pierre is increasing, so his y values are going up as the graph goes from negative infinity to negative 3 in the x-axis. So that's how we would represent this interval. Negative infinity to negative 3 would be the first interval where Pierre is going uphill. Okay, then as he turns at this relative maximum, he starts going downhill, so he's decreasing until he gets to x equals 1. And at that point, at that relative minimum, he turns and he starts going uphill again. And so that's a new increasing interval for this function. And it started at positive 1, and then it continues until x equals 4, at which point Pierre changes direction again. So the intervals over this function where the graph is increasing in y values occur where x is from negative infinity to negative 3, union 1 to 4. And we only use parentheses when we're talking about intervals of increasing, decreasing, and constant, no brackets. Okay, so now we're going to take a look at what happens when Pierre is going downhill. So as we read from left to right, starting at x equals negative 3, so that's where we open the interval at negative 3, all the way until this turning point here at the relative minimum where x equals 1. That would be where Pierre is going downhill. So the function is decreasing between the relative maximum and the relative minimum over that interval negative 3 to 1. Okay, then constant section of this function begins at 4, and then we can see as it goes off the graph here that it remains constant. Remember, a constant function graphs a horizontal line, so from 4 to positive infinity would be the interval where the y values remain constant, and x is from 4 to infinity. Okay, so if you take a second and think about the answer to this question, why are we using parentheses only and no brackets? So Pierre is standing up here at this relative maximum, and he's not moving at all, right? In order to be increasing, he would have to be going uphill. In order to be decreasing, he would have to be going downhill. In order to be constant, he would have to be moving from left to right along a horizontal line. And he's not doing any of those things, right? When he's at the extrema, a relative max or min, he's not increasing, decreasing, or constant. Okay, and that's why the brackets are never used in these intervals, because you can't be increasing and decreasing and constant at the same time, right? He's got to be moving in one of those directions in order to be increasing or decreasing or constant. So we only use parentheses when we're reporting the intervals, the x intervals where the graph is increasing, decreasing, or constant. Okay, so on the front of your notes booklet, that's where we're going to summarize these 3 most important things to remember when we're reporting these intervals. We read graphs from left to right. The intervals only contain x values, and we use parentheses, no bracket. Okay, so in example 1, we have a quadratic function, a parabola that's been reflected in the x-axis, so it's opening down, and we know that these ends are going down to negative infinity in the y direction. So if we remember intervals of increasing, decreasing, and constant, those are x values only. So we don't even care about these values on the y-axis. So just so we don't get distracted by them, I'm just going to cross them out here so that we focus our attention entirely on the intervals along the x-axis where the graph is changing direction. So as Pierre starts over here at negative infinity on the x-axis, and we're reading the graph from left to right, so Pierre is way over here at negative infinity, and he's walking up, 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 up along this curve because it's headed uphill until he reaches this turning point at the absolute maximum, and then turns and starts heading downhill. So the interval where Pierre is increasing occurs from negative infinity until x equals -2, because that's the x coordinate where the absolute maximum is located. So the interval of increasing would be negative infinity to -2. And remember, that's parentheses only. Okay, then after that turning point, the graph, as we start at -2 and we head off to positive infinity in the x direction, these y's are going down, 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 down. So the interval where the graph is decreasing begins at -2, non-inclusive, and heads off to x equals infinity in the positive direction. Okay, so go ahead and pause the video and give examples B and C a try. And when you're ready to check your answers, you can turn it back on and we'll look at those together. Hey, so welcome back. We're going to look at example B and C here together now that you've given them a try. So in example B, the interval where the graph is increasing occurs from 0 to 2. So if we look at this turning point here, this is our relative minimum of 0, and it occurs at the origin where x is 0, and then we can see that the graph is increasing in y values until we reach this relative maximum where x equals 2. So this is our interval here from 0 to 2 where the graph is increasing. Then it's decreasing and picks back up again here at 4, and then from 4 to positive infinity, we can see that the graph is going up, 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 up again. Okay, so that would be our intervals of increasing. Since it's multiple intervals, we join them with a union. Okay, then the graph is decreasing, so looking at negative infinity in the x direction, we're going down, 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 down until that turning point where x is 0, and then we pick back up again here where x is 2, and we see the graph is decreasing, decreasing until this turning point where x is 4. So the intervals where the graph is decreasing would be negative infinity to 0, non-inclusive, union, and then the open interval 2 to 4. So in example C, we can see that the graph is decreasing from negative infinity to negative 0.15, right, the x coordinate of this relative minimum. And then it picks up again, decreasing from 2.5 off to positive infinity. It's increasing in between, so the function increases over the interval negative 0.15 to positive 2.15. Okay, so go ahead and pause the video, and on some scratch paper or an individual whiteboard, I'd like you to take a look at this piecewise function and identify intervals over which the graph is increasing or decreasing. And then when you're ready to resume, you can turn the video back on. Okay, so you can go ahead and check your answers then. This piecewise function is increasing over the interval negative infinity to negative 5, union negative 3 to 0, union 2 to 4, and it is decreasing over the intervals negative 5 to negative 3, union 0 to 2, union 4 to infinity. Okay, you want to double check your notation. All of these intervals should be parentheses only, no brackets. The intervals do need to be listed in order from least to greatest as you read the graph from left to right, and multiple intervals need to be joined with union symbols in between.